today what we're going to be doing is we are going to be looking at diagrams that look like these ones, where you have two lines and then the transversal that cuts through them. And we're going to be finding the value of x that makes those two lines parallel. The way we can do that is by using the theorems we've learned about corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles and their converses to help us find the value of x that'll make those true. And using those relationships we know about those types of angles. So, and also friendly reminder, remember that this symbol here means parallel. So we're finding the value of x that makes line M parallel to line N. So, do we have a special relationship between the two angles that are marked? We do. This angle here and this angle here are corresponding angles. They are on the same side of the transversal, and they are in the same place relative to the two potentially parallel lines. They're both to the right of the transversal and above the two lines that we want to conclude are parallel. The converse of the corresponding angles theorem says that if the two corresponding angles are congruent or have the same measure, then these two lines are parallel. So the way we can find the value of x that makes these lines parallel is if I set these two angles equal each other and solve the equation that we get. So basically what I'm saying is we need to solve 3x plus 5 equals 65 since we know these angles need to be congruent. Solve that like you would any other equation. So subtract 5 and then divide by 3. And we get x equals 20. We are finished at that point because all they need us to find is the value of x. The value of x is 20. If I substitute x equals 20 back into this expression right here, I get 65 for this angle and 65 for this angle. Since these angles are congruent, the two lines are parallel. Let's try one more. Now you may have noticed that these two angles that are marked here do not have a special relationship. They're not corresponding, they're not alternate interior, they're not alternate exterior, they're not consecutive interior. So we can't just go right off the bat and make an equation like we did here. That means we have to kind of fiddle around and use some of the other angles that aren't marked. So I'm going to call this angle right here angle 1. We know that in general, angle 1 and this angle are going to be supplementary or add up to 180 because they make a straight line, they're a linear pair. So measure of angle 1 plus that other one are going to add up to 180 because they are a linear pair. Okay, what else can we say? If we look at just angle 1 and the one that's marked 72, we're back in the same boat that we were here. We know that measure of angle 1 needs to be 72 degrees for these lines to be parallel because they are corresponding angles. So, since this is 72, I can put 72 in for measure of angle 1 right here, substitute that in, and solve this equation to find my value of x. So I'm going to do that down here. 72, because measure of angle 1 is 72, plus this expression here. Need to add up to 180 because these two angles make a linear pair. So let's go ahead and solve this equation. I'm going to start with distributing. I get 4x plus 20 when I do that. I'm going to go ahead and drop my degree signs while I'm at it. Combine my same side like terms. 72 plus 20 is 92. And then from here, subtract 92 from both sides. I get 4x equals 88. So when I divide, I get x equals 22. I am finished because I found the value of x. If I sub 22 in for x, I will get the type of relationship where this angle is then 72, and then my corresponding angles are congruent, which would make these two lines parallel. That is it for this video. Next video, we're going to be looking at diagrams and seeing if we can conclude that two lines are parallel. Have a wonderful day.